Dear students, let's start lecture number 9 on the topic best, worst and expected case regarding time and space complexity of the algorithm of the course analysis of algorithm. This is our today's outline. First, we will discuss previous lecture, which was lecture number 8. Then we will try to understand burst, what are best, worst, and expected cases, and then we will understand time complexity with the help of linear and binary search algorithm. Uh, then we will discuss space complexity, how we calculate space, and then we will try to understand with the help of two examples. Then I'll give you assignment. Then I'll share my recommended reading and websites which I have used in making these slides, and you can also explore those to learn more about this topic. Then I'll share my contact information using which you can submit your assignment or you can ask me any question if you have. So let's start with the revision of lecture number 8. So if you remember that in the last lecture, which was comprised of structured programming, and we mentioned that there are 3 important ingredients of structured programming like sequence, selection, and repetition. We have already covered we had already covered 2 in previous, like sequence and selection, and in the lecture number 8 we covered repetition. So what the repetition, as the name indicates, this is like a loop. Like if you want to execute a statement more than one time, so then you need a loop. So specifies a block of one or more statement that are repeatedly executed as long as condition is satisfied. So as long as condition is true, this loop will be executed, and once this condition gets false, so then the normal execution program will be followed. This is the while structure. Like you can see that you have start, then initialization. Here this is the condition which you need to be true if you want to execute this block, and once this condition gets false, so then it follow the normal sequence of the program. So you can see here that this is the condition. If the condition is true, that this instruction which you want to execute more than one time, so this will be executed, and each time this will be checking the condition, that whether the condition is true or false. If the condition is true, so this will execute it, and then the block will execute, block will be executed. Otherwise, normal execution of program will be followed. So if now we try to understand that what is the advantage of using a loop. Like if you do not use loop, then what we can face. Here you can see that what we are trying to do, that you are being asked to write an algorithm and draw a flow chart to calculate 2 raised to power 4. So here you can see begin, and then you have a base, then you assigning base to the product, and here you can see as this is 2 raised to power 4. So you can see here the product is multiplied by base, and this is you have executed this statement 4 times. If we will see in our next slide that if we use loop, so what will be the what will be the effect of that. So here you can see this is the flow chart. Like you have a begin, and then you have a base, and this is 4 times this the statement will be executed, and then you will get the product, and then product will be printed on the screen. So now you can see that now we are using loop. So we have written only once this statement, and then we are executing this loop 4 times. So this is how we can replace loop structure or controls with a normal sequence. So for the normal sequence, this is difficult. For example, if this is only this, in this example, this is only 4 times, so if somebody asks you to print your name 100 times, so you have to write, you have one option is that write your name 100 times. So, and another option is that you execute loop and write your name once, and then uh, uh, then uh, 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 start that loop, and that loop will be continued till 100 times or 1,000 times, and you can print as many times as you want. So this is how it can make your program efficient, both space wise and time wise. This is a flow chart with a while loop. You can see here that in this statement you have only once a condition is true. If the condition is true, so this block will be executed, and then this will be incremented by 1, and each time this will be checked that condition is true or false. If the condition is true, so the block will be executed, and when the condition gets false, so then it will come out of that loop. Here you can see here that tracing of power 4. This is program, like you have a base, then product, and now you assign at the step 4 you have done base to the product, and then this is initialization of your counter, and then this is counter is less than power, and they here use in 6.1 and 6.2 you can see here that here this is the multiplication of your product, and this is increment for your condition. So here you can see that step 2, the base is 2, step 3, base is 2, as power is 4. You can see here that power is initialized as 4. So step 4, you can see here that now you have a product, you have assigned base to the product, and base has value 2, so now the product value will be 2. So you can see here that product is 2. At the base 5 you can see that counter is 1. So now base is 2, power is 4, product is 2, and counter is 1. uh, and this condition is true at step 6. You can 6 here, the condition is true, and 6.1 you can see here that this is multiplied by 2, and this is counter is 1, and this is true, so the loop will continue. So this will be continue. You can see here this is each time as this is true, so the block will be executed, and at the step 6 this gets false, so your loop will be stopped, and you will get the outcome of this program, which is 16. So write down algorithm and draw a flowchart to find and print the largest of 3. So here you can see here that you have a you will first get the value n1, and then you are assigning n1 to the maximum, because you don't have any other option. That whatever you have received, you are calling that value as maximum, and then you ask your user to enter another value, and now we are checking, because we have two values, and now we can compare that the value which we received second is greater than maximum or minimum. So if as this is a minimum, so this will, and if this is maximum, so this will come, we will receive the n3, and then n3 will be checked, and then we are assigning n3 to the maximum, and this is how we will get the maximum value with the identifying message. And you can see here, this is the tracing of your program, that how your program works. So you can see here that step 2, this is n5, you have entered 5 value, and then step 2 you 5 value, and here you can check here that maximum value is 5, because you have assigned n1 to the maximum. At step 4 you can see here that n1 is 5, and this is 7, and this is maximum, Now N2 is entered, which is 7. So you have at step 4, you have value 7. Now you are checking N2 is greater than maximum. So this is checking that N2 is greater than maximum. So this is true. So at the step 6, you have now you have as you have already entered N1, N2, and now you are entering N3, which you have entered 3. So now they are checking that maximum is 7 and N2 is greater than maximum or N3. So this is not checked yet. So at step 7, you see here that 5 and 7 and 3. So 7. So this is not given yet, and this is false. So the largest value is 7. So uh, you have to draw the flow chart of this program. I have just explained the algorithm and its tracing, and now this is your assignment to draw the flow chart of this program. Now, example for while loop. Example: write an algorithm and you draw a flow chart to find and print the largest of n. Read number one by one, verify your result by a trace table, assume n to be 3, and the following set to be the number of numbers 4 to 8. So this is your assignment. So you can see here that here you have this algorithm and you are entering values, and this is the flow chart. I hope that you understand this, and I have explained in detail in my previous lecture. So I don't want to go into detail, but this is the algorithm, and this is the flow chart, and this is the tracing of the previous algorithm. So this is the you can see here that this is write an algorithm and draw flow chart for computing the value of the following expression where n is entered by user. So you can see here that this is a series of values. So how it works, that you ask user to enter value, and then you are assigning 1 to I, and then sum, and then I is less than n. So definitely this is the stopping condition where you have to stop summing this series. So here you can see here that you are incrementing this counter, so that this each time this will be checked that if condition is true, so this will be summing this series. So this is how you will get the sum, and this is the flow chart of this algorithm, that you ask the user to enter the value of n, that how many n's you have, like 1 by 1, 1 by 2, 1 by 3, and so on. So enter n. So what is the maximum value in your series which you want to sum? So this is that n. So here you can see that this is assigning value to I, and this is how it is checked the condition. So this condition this value is this is processing and preparing the sum, and each time this will be incremented to check that whether we reach to the required number of n value or not. If we reach to the n, so the loop will be stopped. Otherwise this will be continued till the required value. So I hope you can understand this. So I don't want to explain this. I have already explained in my previous lecture. So now come to our today's lecture, which is lecture number 9 on the topic best, worst, and expected case, by considering time and space complexity of the algorithm. So first of all, we have to understand what are the best, worst, and expected cases. So the best case is that, for example, if we try to understand this this by general examples, then we will go into depth, that what are the technical understanding of this, but here in on this slide we have general explanation of best, worst, and expected cases. So the for the best cases, that for example you have you are not prepared and exam is cancelled, or a surprise test when you were prepared. So these are the best cases. But sometimes you get unlucky, and for example questions you never prepared asked in his exams or raining during sports periods. So these might be worst cases for you. And this is expected case or average case. So overall life remain balanced with the mixture of lucky and unlucky times. So this is what we call it average, average case or expected case. I hope that you have understood. So the best cases uh, where you where you get value as you need, or you get the result efficiently, whereas in another case you will not get the result in efficient, and this is the average of best and worst cases. So let's understand these best, worst, and expected cases with the help of examples. So let's consider Algo one. Consider this Algo one. This is very innocent kind of algorithm. And what it does, that, for example, if anybody asks this algorithm that do you have this value, so what it does, that it will start comparing with each value. So for example, if this is the list or a vector, which that algo one has. So if you ask this algo there, do you have this value? Like for example, this A1 is the user and is asking for, do you have this value 8? So what it does, that it start comparing with each value. So what do you think, that what it should say, that uh, does it have this value? So you don't have 8, so the result will be 0 here, if you represent 0 with yes and 1 with no. For example, if algo Algo is asked that do you have this 34 value. So what it does, that it will first compare with the first index and say no, I don't have. Then it will compare with the second, and then it compare with the third one, and then it reaches to the 4 where it has 34. So it say yes, I have 34. So start searching from the list element until element greater than or equal to the number to be selected is found. So this is the general theme of this algorithm. So what do you think there? What would be the best case? So for example, if somebody asks this algorithm that do you have value 2? So as you know that value 2 is present at the first index. So you may call this as a best case. So we can equate this as big O of 1. This is the constant time, and tn means time, and this is take constant time. Okay. So the worst case would be that if somebody asks this array that do you have 56. So what it does, that it starts from the first one, and then it comes to the second, and then it asks from the third, and then it comes to the fourth, and finally it reaches to fifth or a 56, and uh, where it finds its value. So that would be its worst case. So how we can equate this? So this will be this is also take constant time. So big O of n, or you can represent Tn with a nk. So this depends on your input. So I have only 5 elements, but if you have a 5,000 elements, so that will take 5,000 nanoseconds or a second. So this will take constant time. So Now, average case, most of the cases, this is not demanded for the algorithm to calculate average cases. Most of the time, we have been asked for best case or a worst case, but we don't, we generally, or we normally not asked to calculate average cases. And why this is the case, let's see. And then you will understand that why we are normally don't consider, or we don't want to find average cases. So the how we can calculate average or expected case, as we know, the sum of possibilities divided by the total number of cases. So here you can see here that for example, if I explain this with the help of examples, like for example, if I want to calculate average case on this array, so how it would be like, for example, if you uh, uh, if you find this element, so what it will take first one constant time. Okay, so if you try to find this one, so you have 2, and this is, and if you want to find this 3, so if you are here, so how many how much time you will take? So 1k, 2k, 3k, and then nk. And there will be a condition when you don't have this value, you know. These are, for example, if I give you, like here we have been asked that do you have 8 values. So what it does, that it will checks with this one, and then this one, and then this one, and then this one, and finally reach to this one. But uh, but uh, then it will check with the next one also. So that is where the nk comes. So this is the like nk, and this is nk plus 1, where it finds that I don't have this value in my list. So this is the total number of cases. So total is, as you know, that I have 5, but total are 6, because one case is that you don't have this value in your list. Okay, so this is n plus 1. That's why this is n plus 1. So if you take n, take out k as common, so this will be k n 1 plus 2 plus 3 or plus n, and then this will n and divided by n plus 1. And if you see this one, this is a, you can see the arithmetic progression, like 1 plus 2 plus 3 and n. And how we can solve this, by taking n n into n plus 1 divided by 2. This is arithmetic progression. This is not, this is n multiplied by n plus 1 divided by 2 plus n divided by n plus 1. So if you equate all this, you will come up with this n2 plus 3, and this is 2 and 3, these are constant. But if you take this, come to the last one, you can see here, like n plus 1 and n plus 1, they both will be cancelled, and you have a kn, and then you have kn, and this is big of, and this is also take constant time of n. So you can see here that in average case or expected case, normally this is very difficult for us to calculate. Calculate this is very difficult for us to calculate, because we have to take the take the time taken at each step, and then we can calculate the average of that. I think that you understand this thing, that first you have all the possible all sum of all the possible occurrences, then you have a number divided by the number of cases. So then you will take the big O of that. So big of sum of the all possible, all possibilities divided by the total number of cases. Now come to case number 2. This is called binary search, you know. So if you, for example, take this, I'll complete this in my next lecture, but for the time being, I just go through it. like how we will perform. Like this is algorithm 2, and as a name indicate that this is a binary search. So how it works, that if you want to find anything, the what it does, that it divides. Like you can see, for example, if I want to find 20, so what it does, that it will divide this into two pieces. Like at the beginning, what it does, that it will compare with the first and last element. So if it finds this, this would be the best case. Otherwise, what it does, that it will divide the total list divided by 2, and you will get the mid. So this will compare with the mid. If you find this element like 20 at the 5th position, so this will be the best case. Otherwise, what it does, that like for example, if you divide this, you will get 56. Now as you are searching 20, so the 20 is greater than 56 or less than 56. uh, what do you say? What do you say, that 20 is greater than 56 or less than? This is less than 56. So this comes under this list. So we will discard the element which are greater than 56. So you reach here, so the rest of the list will be discarded, and then we will divide this 5 divided by 2, and you will get 3 or 2. So if you have 3, so you will compare with third one, which is 32, and compare that whether this is the element which you find or no. So as 20 is not this one, so what it does, that you will divide, you will check that 20 is greater than 32 or less than 32. So this is less than 32. So the rest of the list will be discarded, and you come under this 10 and 20, and then 2 will divided by 2, and you will get 1. So then if we compare with this with the left with the right, so this will get 20. So this is how we find the element. As you know that we have a big list, and what we did, that we divided the big list into half. So then we will check that whether this element is on the left or right of that value, and we will keep on dividing this list to get our required value. Like you can see here that worst case, suppose we have these we have 8 or 6 element in the list. So like you have 8 elements, so if you don't find this element at the start and beginning, so you will divide 8 by 2, and you will get the mid. So you will reach to 4. So the big list will be divided into 4, and then 4 will be divided by 2, you will get 2, and then 2 will be divided by 2, and this is how you will reach to your required number. So if this is 16, so 16 will be divided by 8, and then 8 will be divided by 2. And if you see this thing, like if you have a 8, and in 3 steps you will reach to your answer. Similarly, if that value is present in the list, if you have 16, and you will get divided your list by 4 steps. So if you see, this is a kind of algorithm, kind of a log. So we can say that the worst case would be big of log n. So this is the procedure of like how number of times you can divide your list. So for the 8 you divide list for 3, for the 16 you divide list for 4. If you write like this way, you will understand that this is log n actually. So the worst case will be log n. So what do you think that for the algorithm, which one we need to focus, best or worst? So I hope you will answer worst, because best cases, worst case is the case which we normally consider for the algorithm. So as we have to consider the space, but we will complete this in our coming lecture. So this is your assignment. You will calculate time and space complexity of a function that calculate the factorial of a given number n. So this is, you have a 1 week time. So you, in a 1 week, you have to submit this assignment through KCMS or WhatsApp, or you can email me. My email address is listed down at the bottom of this slide. So these are the recommended reading which I have used in making these slides. You can consider or use these slides to explore more about this topic. If you have any question, you can ask me through KCMS or WhatsApp me or email me. I'll be more than happy to answer your question. With that, we reach to this lecture, till next lecture. Allah Hafiz.